Alright guys, we're going to go over the first week of workshop in engineering math. So there's a few things we have to go over, so bear with me. Alright, so we're going to first go over the two different types of differential equations we're going to see in chapter 1, and that is going to be of the two different types of, they're going to have two different types of solutions. Now the first type is going to have solutions of e to the rx form, and then the second type is going to have solutions in the form of x to the r. Okay, so now I'm going to explain what the two look like and how to tell them apart. So this is y. This one is going to look like y double prime plus a y prime plus b y equals 0, and this one's going to look like x squared y double prime plus ax y prime plus by equals 0. The difference you see is that there's x's, but this may also be seen, so you don't get confused, in this format. All they did was divide by an x squared, and you end up with this. And this is actually how the book has it, I think. So here we go. So the difference is this has x's, this one doesn't. So we're going to go over how to do this. So first thing you're going to want to do is you're going to want to rewrite it. Okay, you're going to rewrite it with r's. R squared, because of the double derivative, plus ar plus b equals 0. Okay, well, now you're going to want to factor out. Okay, so to factor out, I'm actually going to have an example, and it's a simple example where a equals 5 and b equals 6. So we're going to have r squared plus 5r plus 6 equals 0. We factor that out, we get r plus 3, r plus 2 equals 0. To solve, you just set each of those brackets equal to 0, r equals -3, r equals -2. And normally we do this in our head. I'm just showing the math. So then our solution, given our r's, is going to be y1 equals e to the -3x. y2 is going to look like e to the -2x. Now, I'm going to go over a special, what happens if your r's are the same. If you have r's that are exactly the same, equals 2, which equals r2. So if r1 and r2 are exactly the same, this is what you do. Your solution is going to look like this. E to the 2x, and our y2 is going to equal x e to the 2x. You're going to multiply by x, by one of them. Okay, so that's how you differentiate the two. All right, now we're going to go over this type. It's almost exactly the same. You're going to want to rewrite it, okay, with the r's. So we have r squared plus ar plus b. Now the only difference is you're going to have a minus r. Very important. It's only done in x to the r types. So you're going to have a minus r at the end there. So we're going to have an example. Okay, a is going to be 6, b is going to be 6. And this gives us r squared plus 6r plus 6 minus r equals 0. R squared plus 5r plus 6 equals 0. See how these are exactly the same? We're going to get the same root, but that depends on what you have. So r equals -3, r equals -2. So then our solution is going to look like this. y1 equals x to the -3, y2 equals x to the -2. Now, what happens if this has the same r? If r1 equals r2, and in this case we're going to set it equal to 2, you have to multiply by natural log of x. I'm going to show you in this example. y1 equals x squared, y2 equals x squared natural log of x. Okay, so that's how you do those. Now, let's go on to the special case that we went over of e to the rx, and that is complex roots. Okay, so this is e to the rx with complex roots. Okay, What does complex roots mean? You can't factor it out. So we're going to have the same thing. AY prime plus BY equals 0. But in this case, it's going to be a complex root. So we're gonna rewrite it. That's always a good thing to do. It helps you see it. R squared plus AR plus B equals 0. Now here, if you tell you can't rewrite it, you're going to have to use a different solution, either the quadratic equation or a simpler way I'm going to show you. So we're going to have an example. Okay, this is if you can't factor it out. You're going to have A equals -2 and B equals 5. Okay, so for this case, we're going to try and factor out r squared minus 2r plus 5, and we're going to see we can't. So we're going to have to use this equation right here, r squared minus 2ar plus a squared plus b squared. Note that these are small a's and b's, which means they're not the same as these top ones. And this is going to give us our r, because r is going to be a plus or minus bi. Okay, and our solutions are going to look like this. y1 equals e to the ax cosine bx. y2 equals e to the ax sine bx. Okay, now we're going to solve this problem using this equation. We see that a has to be 1 to satisfy this equation, so we have a equals 1, and in this case 1 squared plus b squared equals 5, so b squared equals 4, which means b equals 2. And that means that our r equals 1 plus or minus 2i. So that means y1 equals e to the 1x cosine 2x, and then y2 equals ex sine 2x. So that's how you do in complex roots if you get confused. Now, we have to move on to finding differential equation. That's what DE stands for, given a solution. What does that mean? Well, it's going to look something like this. Y equals c over x squared minus 6. If there's a c there, you know that when it says find the differential equation is anything like this, where it's just y prime, y double prime, y prime, y equals something. So we want to get back to that, no c's. So what we have to do is first we have to take the derivative. Okay, so we're going to take the derivative and we get y prime equals, okay, the derivative of this is going to be what, -2c over x cubed, and then this is going to be technically minus 0 because the derivative of 6 is 0. So we're going to have that, and now we're going to solve for c in one of them and plug it into the other. So let's first solve. I'm going to do this one just because it seems easier. X cubed over -2 equals c. Now 3, we're going to plug into other equation, the one we didn't use to solve for c. Okay, so we're going to plug it into the original. So y equals y prime x cubed, technically it's a negative, over 2, that's where our c went, which means we have to divide by x squared and we have to subtract by 6. Now, we want to have all our y's on one side and the constants on the other side, right? Just like this, equal to a number. So we're going to add this to the other side, and we're going to get y plus y prime. This is going to simplify to just have an x to cancel out, over 2 equals -6. Now we want to have y prime as having no other integer value except for 1. And so we're going to have y prime x plus 2y equals -12. And that's how you do it with those types. You just take the derivative, solve for c, and plug it into the other equation, and just put your y's on one side. All right, so lastly this week, we went over linear equation, the solution to linear types of equations. Now these are first order, which means it's only y prime, and there's actually 3 other ones, but all we're going to be doing for this week is the linear. So then this, the previous thing in this is in chapter 2. So now we're going to do linear. Okay, so the form is going to be in just like this. It's going to be y prime plus p of x, y equals g of x. Okay, now this is the form. Now to solve, you have to multiply both sides by e to the integral of p of x dx. Now, p of x is just this function. P of x and g of x just means that it's a function of x. So I'm just going to do an example because it's the easiest way to do it. To explain, we're going to have x y prime minus 2y equals cosine of 4x x cubed. Now, the first step is going to be putting it into this form. You see how there's no x there? Well, so we're going to have to divide by x. Y prime minus 2y over x equals cosine 4x x squared. Now what's right? So our p of x is going to be what? Negative 2 over x. And our g of x is going to be cosine of 4x x squared. So now we're going to do this part. E to the integral of negative 2 over x dx. Okay, what's that? This is going to be e to the negative 2 natural log of x, if you pull out that thing. Now, using the logarithmic cube rules, we know that if it's multiplied by it, we can put it inside and raise whatever is inside by that power. I want to show you. Natural log of x to the negative 2. So we made that the power of what's inside. Now, we know that e and natural log cancel out, which leaves us with x to the negative 2. So multiplying both sides by that, we get y prime over x squared minus 2y over x cubed equals cosine of 4x. Now, here we want to take the integral of both sides. Now, the integral of this side is, if you did the last part right, it's just going to be this first term without that prime. So we're going to have y over x squared equals the integral of cosine of sine. And because of this 4x, we have to divide by 4 plus c. Now, to prove this, I'm going to just take this derivative of this one and prove to you guys that it is equivalent. So to use the product rule, this makes it into a product, the derivative of product. So this, taking the derivative, we know it's derivative first times the second, plus first times the derivative of the second, which is negative 2, x to the negative 3. Rewritten, it's y over x squared plus y negative 2 y over x cubed, which is what we had here. So I'm just proving that that works, and that is what we end up getting for this type of thing. The only thing is you want to solve for y, so y equals x squared sine, of 4x over 4 plus cx squared. Okay, so this is what we want to end up with, y equals. So that is how we do all of the week 1 of workshop. Thank you guys.